Hey, welcome back to yet another day on data science and machine learning with Python. Yesterday we worked on building a movie recommendation system based on the popularity of the movies. So this type of recommendation system was known as popularity-based filtering. So we filtered out the movies which were the most popular. Today we're going to do two other types of recommendation systems. First will be content-based. So we're going to show movies which are similar to a certain movie. And then we're going to do collaborative-based filtering, which means we're going to show movies to a user based on what they've liked, how they have rated other movies in the past. So let's do that in the next video. In the next video, I'll also give you a CSV file we're going to work on. So I'll see you there. Hi again, in this video we will build a content-based recommendation system to recommend movies which are most similar to a certain movie. So to do that, we're going to work on a new Jupyter notebook. So if you are working locally on a local Jupyter notebook, I do recommend you to create a new Jupyter notebook file. If you are working on Deep Note, I recommend you to stay in the same project. So my project is movie recommendation system, but instead of working on the same notebook as this previous one, I will create a new notebook. For that, I'll go to this section. So if this is hidden, you can hide it and show it with this button. So you go to notebooks, press the plus icon and name the new notebook to Notebook 2 perhaps, or content-based filtering. I'll just go for Notebook 2. And yeah, let's start our first code block. And we want to import pandas here. And again, you can either use pandas as PD or just pandas. And this time, I prefer to work on a smaller version of the movies.csv file. With less data, we're going to use only 6 rows of data. So please download the smaller version of movies.csv from the lecture resources. Once you download the file, you want to go to Files, plus icon, Upload File, and select that movies_small.csv file. And you want to perhaps store it in movies variable equal to pandas.read CSV. I'll tell you why I chose to work with this file this time and not the main file we used to work in the previous videos. So movies.small.csv, and then just execute that with Alt-Enter to execute that code and create a new cell, or Option Enter if you are on Mac computers. And movies, I'll just print out the entire movies here, right? And if you get this error, don't worry, this happens because this time this CSV file, the columns of this CSV file are separated not by commas but by semicolons. So in that case, you want to change the sep argument, which by default is equal to a comma. So by default, the read CSV method assumes that the columns of the CSV file are separated by commas. But this time we want to change this to quotes semicolon in between. So execute that again with Ctrl-Enter this time. No errors, we got the check mark. And yeah, execute the movies variable and you're gonna get this. So this time I didn't do .head. I wanted to show the entire data frame because it's a small data frame consisting of only 6 rows. So 6 rows and 1 header row. So this time I chose to work on smaller data because it will help you understand the process and the algorithms we will use to do content-based filtering. So it's better to start with smaller data, and then you can simply change this code to apply to your main file by just changing the name here to movies.csv and execute the cells again. So I do recommend you to work on the smaller version of the file along with me. And yeah, let's create here a heading 1. So this is content based filtering. Right. To do content-based filtering, we need to work on the overview field. So the overview field contains a description for each movie. So what we're gonna do is basically we're gonna compare the description across all the movies. So if the user is browsing currently Kung Fu Panda on Amazon or Netflix, then we want to show similar movies below that movie. So we want to recommend the user similar movies. And the way we're going to do that is by comparing the Kung Fu Panda description with the descriptions of other movies. So the movies which have the closest description to Kung Fu Panda, those movies are the ones that are going to show below the Kung Fu Panda movie. So those will be the recommended movies. And to do this sort of comparison across different pieces of text, so we want to compare every piece of text with every piece of text. And to do that, we're going to use the scikit-learn library, which can be imported with imports sklearn. Now, if you're using Deep Notes, you don't need to install this. But if you are using Jupyter Notebook, you can install it with pip install scikit-learn or -learn. So that's the command. Once you install scikit, then you can import it, but I'd prefer to just do from sklearn. So instead of importing sklearn, I'll do sklearn.feature extraction feature_extraction.text import tf-idf vectorizer. This is a class we need to vectorize the text, basically, which means that the text has to be converted into some coefficients, some numbers, basically, to be able to compare the similarity of those words. So those numbers are going to represent the importance of each word in the entire data frame. So I'm not going to go deeper right now into what we're doing here, because I want to show you the results, and then I want to explain you by referring to those actual values and explain you what those values mean. So for now, let's just keep going with the code. So once we import this class, then we want to call that class, so create an instance basically using that class. This can get a stop words argument, which is equal to English. Now I'll go back to this stop words again later on, so let's just keep it as it is. Now I'll explain you why I'm doing this, and then we'll do movies and access the overview column. So that will give us, just to demonstrate to here in another code cell, so that should give us this series with the descriptions only. So think of this like a list of text of strings. So each string represents the description of a certain movie, and we have 6 strings here. Right, so let me I'll keep it here just for reference. So what I'm doing here is I'm just getting rid of non-values using the .fill na methods. So I'm going to replace the non-values, if there are any. In this small data frame, we don't have such non-values, but if we have them, we just want to convert them into a string, because the following methods will need strings instead of non-values. So in that case, we just have empty strings for those non-values. So that will change this overview field. So I'll execute this cell for now. Yeah, just like that. Execution successful. The overview column is still the same, obviously. And let me add another cell here. So this is going to be tfidf underscore matrix. This is going to be equal to tfidf, so this matrix here, dot fit transform, and we want to transform the movies overview field. Right, execute that, and in another cell you may try to display this matrix now, but you're gonna get this output. So it will not display the matrix right away, but we can display this better using toArray, a method. Execute that, and you get this, which it's still not ideal. So for a better view, I would go for pandas.dataframe, so the data frame class of pandas, and wrap this around that data frame class. So we're wrapping this numpy array inside that data frame class. And so if you execute this now, you're gonna get this, and you can improve that by adding here columns is equal to tfdf dot get feature names, and execute. Oh, sorry, it's tfidf, so it's this variable here, which points to the tfidf vectorizer. So execute that, and yeah, there we go. So now let me explain you what we are doing by referring to this result here. So what you're looking at is a data frame or a matrix. Basically, a data frame is a matrix, and this matrix has 6 rows, well, 7 if you also count the column names here. But basically we have 6 rows which correspond to the number of movies we have in our data frame. So we have 6 movies, right? So the first row represents the first movie. Now, 26 here, an abducted, an accuser, an adventure, an adventures, an assumes, attorney. These are all words, and there are about 100 something. We can find that out by using tfidf underscore matrix dot shape. So it's 121 columns and 6 rows. So tfidf, right? This is tfidf, but as a data frame, we are converting it to a data frame. So this data frame has this number of words. So 121 is the number of words in total in all these descriptions. So then we have the first movie we said, right? So 26 is also a word. It's mentioned somewhere, so it's counted as a word, so it's 26 years. Of course, there are ways to manipulate the data so numbers are not counted, but that's another subject. So 26 abducted. So the first movie has 0 occurrences of the abducted words, 0 occurrences of accuser words, and so on and so forth. Now for brother we have 0.333, etc. Why is this number here? Well, that is the value of tfidf. So this matrix contains the tfidf values. What is a tfidf value? Well, this value is indicating the frequency of the word brother in the first movie. The first movie is Furious, right? But it's not only that. This number is indicating the frequency of that word in that movie, but also the rarity of that word. Which means if brother is very frequent in the description of this movie, so it's mentioned 1, 2, 3 times, and also that word is a rare word in the entire description of the data frame, that word is going to have a high coefficient, so a high weight. And this is called term frequency inverse document frequency. So it's two parts, right? Term frequency, so the occurrence, the frequency inside that single description, and the frequency in the entire data frame. But it's the inverse frequency, so it means the rarer the word, the less frequent the words in the entire document, the more weight it will have. So it's like a unique word for that movie. It's something that tells that movie has something unique, and this word should have such a weight. So basically that's the idea. And yeah, we have the same thing for the other rows. So for example, movie number 3 has this coefficient for 26. So 26 can be found in this movie, the third movie, with index 2, Guardians of the Galaxy. So why do we need this matrix now, you'd ask? Well, we need this because, with this we were able to transform the words into numbers. So now the next step is to create another matrix. And so in this other matrix we'll have movies here in this columns and also the same movies in the other columns, and then we're gonna have a coefficient of similarity between each movie. So we're gonna have a coefficient for the first movie and the second movie, so how similar they are, the first movie and the third movie, the first movie and the fourth movie, and then fifth, sixth, and then the second movie and the third movie, and so on. And so by having that new matrix, then we are able to tell to the user that, oh, if they are watching this movie, then we find the coefficient and we find the highest coefficient that movie has with which of the movies. So we're gonna see how to do that exactly in the next videos. So I'll see you there. Hey, welcome back. Previously we produced this matrix of the weights of the words. For example, Adventures has this weight in the movie with index 3. Assumes has this weight in the movie with index 4, and so on. So each movie has different words, and different words have certain weights, and so on. So far so good, but we need another matrix here. We need a matrix that has the coefficients, and these coefficients should indicate the similarity between each pair of movies. Let's build that matrix here. First, let me create a heading 3 cell above this. So let's say similarity matrix. So to produce a similarity matrix, we need to import from sklearn.matrix.pairwise import linear kernel. Now there are different functions to do these, different algorithms. So we have the cosine similarity, we have linear kernel. These algorithms are very similar, but linear kernel is one of the fastest ones. So this is what we're going to use now. So once you import linear kernel, then all you have to do is just write a variable like similarity matrix is equal to linear kernel. So you call that function, that is a function, and linear kernel now gets as input a matrix of word weights. So that would be this matrix here. No, sorry, this is the pandas data frame. It has to be the array, the numpy array, which is in tf-idf matrix. So this one here, that variable. So it goes here, and we actually provide 2. So the same input twice. So basically we're looking at pairwise analysis here. So we want to cross these two matrices together. And yeah, let's execute this with Control Enter. Oh, in case your notebook was stopped, as it was in my case, it will take a while and it will tell you probably that, oh, TF IDF matrix is not defined because these cells have to be again executed now since we lost the connection with the server, with the deep node server. In that case, you want to press that button, Run Notebook. And that will run all the cells of the notebook one by one, so redefining the variables again. And so you know that the execution will be complete when you see all the check marks. So the last cell has a check mark. That means this code was executed now. So that was the case if the machine stopped. Otherwise, you wouldn't get that issue. So then I want to just call that matrix, or which I've mistyped. So let me quickly do matrix here and matrix here, but execute this again since I've now changed the variable name. Execute this as well. So that's the matrix now. That's the matrix of similarity. Let me explain you what these numbers mean. So this is a NumPy array, and if you can check the shape, so let's add a new code cell, similarity matrix.shape, you're gonna see that it's 6 by 6. So we have 6 movies, and if you get the first index here, 0, you're gonna get the first list. So think of this array as a list of lists. So a list of lists, and that is the first list. That's the second list, and so on. So we just got the first list here, that one. If you do here 1, you're gonna get the second list. So which is this one in here. So what are these numbers? What is this second list? Let's focus on the second list. So the second list points to the second movie, which is, let's go back here. The second movie is this one here. So that's Cars 2. So the second movie has these similarity coefficients. So that means the second movie has a similarity coefficient of 0 with the first movie. So the first movie is Furious 7. Now you'd ask, aren't these movies actually similar since they are about cars? Well, they are, but our analysis here are limited because we're only using the overview column here to judge the similarity between movies. So for more accuracy, you would have to also take into consideration the other columns, such as keywords, and then you have the cast in the other CSV file, credits.csv file. So you could join the keywords column with the overview column to get more accurate results. So that's something I wanted to note here. And let's continue with the explanation of the matrix here. So we have then the second number is 1 because this is comparing movie 2, so it's list 2. So the second movie is being compared with the second movie. So that's why we have 1 here. And actually the diagonal here, you can see it's all 1s because it's comparing the n movie with the n movie, so the movie with itself. And then the 0 is the coefficient of the similarity between this second movie and the third movie, second movie and the fourth movie, second movie and the fifth movie, second movie and the sixth movie. So this one here seems to have some sort of similarity because obviously there were some words which were similar between the two, and so on. And so that's about this video. That's how you calculate a similarity matrix. Now in the next video we're gonna go ahead and find the most similar movies to a certain movie. So let's do that in the next video. See you there. Hey, welcome back. In this video we want to create a function, something like similar movies. So we want to define it. This function will get a movie title and a number of movies, and it will return X number of movies for that movie title. So if the user wants 5 movies for that particular title, then we will return the 5 most similar movies for that movie. So that will be in a list, so a list of movie titles. So let's do that. Before I write the lines inside the function, since we are in a Jupyter Notebook style of coding, it makes sense to actually write the lines before that, so we can see the output line by line, instead of having everything at once and then calling that function. So let's try to understand the process here, and then we can just copy those lines or cut them and paste them inside the function. So what we have is the similarity matrix, right? Which is this one in here. Let me delete this line, we don't need this, where we are just printing out the first list of the matrix, which is actually an array on itself, but it's a one-dimensional array, so it has only one list. This here is considered a two-dimensional array. It has a list of lists, and then you might have 3 dimensions if you have a list of lists, and so on. Anyway, so let's delete this line. So let's say we have the movie title. Let's get one of the movies. So let's say the user wants to know what are the 3 most similar movies to this movie here, with title John Carter. Here, let's have that title here. So let's store that in a variable as a string, John Carter. So with capital J and capital C, the string has to match exactly the title in the data frame. So movie John Carter points to this list. So that is the list of similarity coefficients. So that means John Carter, that movie, is 0 similar to the first movie. The first movie is Furious 7, right? And then John Carter is a bit similar to this movie, then 0 again to the third movie. This is 0.03, so that's quite okay, and so on. So we have the list of coefficients, but we need to find a way to order, to sort that list, because the list currently is unordered. So we need to order it by descending order, right? So which means 1 will be the first. Well, we will need to exclude 1 from the sorting, and so actually this would be the most similar movie to John Carter, and then followed by this, and then by this. So we need a way to sort this matrix. So let's execute this cell first, movie title. We leave it there, and then in another cell we can do something like sorted similarity matrix, and we do 5 here. So John Carter has an index of 5. That would give us a sorted similarity matrix, and you could say something like reverse is equal to true. So that would give us that matrix in descending order. But we have an issue here, because we didn't provide the movie title in here. So we need a way to convert John Carter into an index. So we need a way to find the index of John Carter automatically and not hard-coded inside here. We can do that in a cell here by using the data frame name, which is df. Let's see, the data frame is movies. Movies holds the data as a data frame, so that would be movies. dot lock square brackets, again movies square brackets, this would be the title column, and inside the outer square brackets we say this title is equal to movie title, so it's equal to John Carter. And so this IDX now gives us a panda series object, which we still need to process using index and then 0 in here, and that will give us 5 finally. So basically we are filtering the data frame. We're saying, oh, give us only the rows which have title equal to this string, John Carter, right? So that will give us all the rows, which happens to be one row, and then we apply index, and then we get only that number, the number of the index, which gives us 5. So now we can use IDX here. So by just having the name of the movie, the title of the movie, we were able to calculate the index and then sort the matrix. Right, so far so good, but we have a couple of issues here. The first issue here is that this is just a list without indexing. So we sorted the list and then we lost track of which coefficient points to which movie. So does this point to movie number 3 or movie number 4? We don't know that. So before we sort this, we need to use an enumerate function. So that would get this list of coefficients. So that is the last list here, right? This last list. And we also need to convert this into a list and store it in some variable like scores. And let me print out the variable here. So now we get this. So note that I did that before sorting the items, and then we can sort that here, but now we sort the scores, right? We sort the scores, and if you execute this, you're not gonna get the actual results, because this is sorting the scores list of tuples by the first item of each tuple, which is the index, right? So with that enumerate function, we produced an index. We assigned an index to each of these coefficients. So that means this first coefficient got an index of 0, this second coefficient got an index of 1, and so on. So we're keeping track of which coefficient points to what movie, basically. But here, this sorted method then sorts these tuples by the first number. If you want the tuple to be sorted by the second item, which is the coefficient, then you want to apply a lambda function. So key is equal to lambda. So x colon x with 2 square brackets, and you do 1 here and a comma here, so that's one argument, and this argument is equal to a lambda function. So a lambda function is a one-liner function which you can define. Usually it's useful inside these function calls, so where you don't have space to create a function with multiple lines. So basically this method is designed to look for lambda functions in the key arguments. So you see we are extracting the item with index 1 from each tuple, right? So that's a first tuple. This tuple has these two items. The first item has an index of 0. The second item has an index of 1. So we're getting the item with index 1. And we are sorting this list of tuples based on that second item, right? That's the idea here. So if you run that, you're gonna see that this time we get the tuples sorted by their second items, which are the coefficients, the similarity coefficients. But note that if I call that scores method here, you're going to see that it loses the sorting. So what you want to do is you want to reassign the variable to this sorted list of tuples. So do that, scores is equal to sorted, execute, and then you can execute scores again somewhere else, and you'll see that now the changes have been saved and the list of tuples is sorted by their coefficients. So basically what we did here is that now we know that the movie with index 5 has these three most similar movies, right? So all we have to do now is just extract those movie indices using something like a list comprehension. You can say something like tuple TPL, so just a variable, TPL. TPL, I want to extract the index from each tuple, so the first item. That's why I wrote 0 here, because this item has an index of 0. For TPL in scores. But we don't want to iterate the entire list, we only want to iterate from 1 to 4. So we are iterating over these three, right? Because when you say 1, that means this is not considered, since this points to the similarity of the fifth movie with the fifth movie, so that's something we don't want, and therefore we leave that out of the movie indices list. So see what we get here. Movies indices, so you'll see for yourself. Oh, sorry, movies indices. So that's a list of indices 3, 1, 4. So 3, 1, 4, the three most similar movies to this movie. Right, but we have the indices, but we don't have the titles. So let's see how we can get the actual titles for those three similar movies. We need to point to the movies data frame. So the movies data frame is this one in here. So we want to extract the title, right, of each movie. And to do that, we use iloc. So you can give a list of indices here, such as 0, or 3, etc. But we have the list here, which is this movie indices. So I'm just going to place that here. So iloc square brackets movie indices, closing square brackets, execute that, and yeah, we get a panda series with the names, with the titles of the movies which are most similar to that movie. Now you could also convert this into a list if you just want a plain Python list made of 3 strings. So there we go, that's how you can calculate the titles. But let's finish this function so that we can call this function later on, such as similar movies. You call it with any movie title, such as Kung Fu Panda 3. That's one of the movies. It's so this one here, Kung Fu Panda 3. So I got the name correctly typed in here, yes. So if you call that function and you say, oh, I want the 3 most similar movies for that movie, then this function should give us this list. So let's quickly implement that function. We already have the code, so all you have to do is you get all these lines. So starting from this, where we calculated the index given a movie title, so you paste that in here. Then the next line after that is we calculate the scores, so the list of tuples. So these are the scores, the coefficients that indicates how similar this movie is with all the other movies. So movie title will go here, right? We get the index of the movie title. We get that index then passed in here. So we get the scores. Then next is we get the scores sorted out by the coefficients. And then we have, next we have movie indices. So this one here. And after that, so after the movie indices, we have the list of titles. So we convert that into titles. Let's paste that in here as well. But this has to be changed to number of movies. So this is dynamic. So we say number of movies plus 1. Since if the user gives 3 here, so they want 3 movies, then we want to place 4 here. Therefore, we increment it by 1. And of course, we need to return something. So let's say similar titles is equal to that list, and then we return, you guessed it, similar titles. So execute that function definition, and then you execute the call, and you get these for Kung Fu Panda. So these are the 3 most similar movies to that given movie. So that's how you can build a recommendation system based on content. Of course, this is limited, as I previously mentioned, because if you want to have more accurate results, you may want to take other information into consideration, such as genre, and the keywords of the movie are also important. So you could join all these columns together, or you could extract these IDs. So you'd have to study these data bits if you want more accurate results. And of course, you can apply this analysis to the bigger database, so to movies.csv instead of movies-small.csv. That of course will give you more accurate results. Of course, that's something we can try here. So let's select movies here. Let's make sure it's here. Yeah, so it's here attached to the resources. So I can run this notebook, and by pressing that button, that will execute all the lines one by one. Oh, this doesn't have to have that separator. It simply has a comma separator. So that's why we got this error. So let's run again. Alternatively, you can just remove this sep argument, since by default it's a comma. And so it's running. That's a long list. The scores, let's see the end results here. So there we go. Similar movies for Kung Fu Panda 3. Kung Fu Panda 2 is obviously the most similar one. And then we have this other one. And then Once Upon a Time in the West. Well, I don't think so. Anyway, as I said, we need to implement more. We need to integrate more data into the calculations, because the overview column here, it just like 1-2 sentences perhaps. So that's very, very little information about the movies. And of course, if you were building a web app where you show movies to the users, you could just integrate this function into that web app. So integrate it with your code, have your web app code run this function, and then that code, that web app, would display those titles to the web page, and perhaps some additional thumbnails and links to click and watch the movie and so on. So thanks a lot for following this, and I'll talk to you later. Hey, welcome back. In this video you will learn how to do machine learning in Python. So far we were in the realm of data science, and now you'll see what's actually the difference between data science and machine learning. So this time we're going to work on building a movie recommendation system using collaborative based filtering. So let me explain you what we'll do exactly. Well, first of all, I'll give you a database which looks like this, so you can download this from the lecture resources. Actually, I gave it to you also in the beginning of this app, but you can find it there again. It's the same one. So this CSV file is made of 4 columns: user ID, movie ID, rating, timestamp. So user 1, user with ID 1, has given several ratings for several movies. So for example, for movie with ID 31, it gave a rating of 2.5 at this timestamp, and then the same user gave this 3.0 rating to this movie with ID 1029, and then we have another user which also has given several ratings, and we have more data. So this is the data set we have. Now let's go back to this figure and explain you what we will do. So we'll do collaborative based filtering. So the purpose here is to predict what a user might like watching, right? To do that, we're gonna find users who like and dislike similar movies. So for example, this group of users, they all gave poor ratings to movie X, and they gave very good ratings to movie Y, so considering a rating from 1 to 5, and then poor ratings to another movie and good ratings to this other movie. So we know that from the data, right? We have multiple users with user IDs, and we have multiple movies. So this is the known variable. We have the data set. But then one of these users hasn't rated another movie, right? The other users have rated it with higher ratings such as 4 or 5, but we don't have a rating from this user. So what we do is we predict a rating for this user. And we do the prediction using a machine learning model, which we'll train through these videos. And so then we use that model to predict a rating. So if the rating is high for this user, for this movie, then we show that movie to that user. So we recommend that movie. So let me tell you now how we're gonna implement that. So we're gonna start from the dataset, which I already showed you. And then we're gonna build a train set, which is basically the same data, but in a different format. So we need that format, that train set, to train the ML, the machine learning model. So initially the model is ignorant of our data. That's why we have to train it. And then once we train the model, then we can predict. Predicting means like providing the model with a user ID and a movie, and then we can get out the rating, the predicted rating that user would give to that movie. So we can do that as many times as we want for several movies, for several users. So that's why we need to build a model. So I hope that's clear what our purpose is and what we'll be doing. So with that, let's get into practice and build some code in the next video. See you there. Hey, welcome back. As I mentioned in the previous video, we're going to do collaborative based filtering, which is a machine learning process. So for that, I'm going to create a new notebook in this project. So we are in the previous notebook currently. Therefore, I'm going to expand this and go to notebooks and create a third notebook here. So just press enter to give it that name, notebook 3 or whatever you like. I'm going to create a first heading here, collaborative based filtering. And so first of all, we want to import pandas and load the data. So ratings is going to be pandas.read CSV, and make sure that the ratings.csv file is uploaded here. So it is here, in my case, ratings.csv. So I'm going to read it. And just get a peek of the data, just to make sure that the data are correct. So it looks good. 0, 1. So again, we have user IDs. Like for example, these are all ratings for user with ID 1, 1, 1, 1. So that's the rating for the movie with ID 31, and that is the rating for the movie with ID 1029, and so on. We also have a timestamp when the rating was given. So that was load the data. Let's keep going. The next one is create the data set. I know this sounds confusing. What is the data set? Because we already have the data, but these data are in a pandas data frame, right? But we're going to use a scikit-learn model. So a machine learning model from the scikit library. And that model requires a specific data type. It doesn't work with a pandas data frame. A pandas data frame is good when you're doing data analysis and so on, but it can be slow when you do heavy processes that require processing of big amounts of data. Therefore, we want to import from Surprise, which is a sub-package of scikit. So you need to install it with pip install scikit-surprise. So, and with the exclamation mark in front, since we are inside a Jupyter, a notebook here. And you may need to wait a while until the installation is complete. While the installation is processing, and I'll create a new code cell and import from Surprise. So notice that we don't use it as scikit surprise, but simply surprise for short. Right, so that was complete. You can press this move package scikit surprise to requirements if you like. That's not necessary, but that will create basically a requirements.txt file here, which can be needed if you want to port this project into some other instances. So basically I just deleted that cell. And I'll do from Surprise import dataset. So as I mentioned, this is going to be a specific class. So you can see it's a dataset class. It's a specific object. And then out of that, you want to create the dataset. So a variable which points to dataset, this class. And this class is instantiated using the load from df method of the class. So it's a class method. And we want to give the ratings here. And I'm going to give only the portion with the user ID, movie ID, and rating, not the timestamp. So you can either do that here, or what you could do is you can simply cut it at source. So it should be something like this. User capital ID. So that's one column name in quotes. Movie capital ID, and then rating. So only these. If I execute the cell again, I'm gonna get a data frame, but without the timestamp. Right, and then I can simply pass here the ratings data frame. Correct? So ratings now has these three columns. Plus here we need something else. Something called a reader, which we need to create before this line. So the reader is going to be something like this, and this is a class which should also be imported from Surprise. Using this class, basically you specify that you are working with rating data, and which come to a scale with a scale of 1 to 5. So the ratings that the users are giving range from 1 to 5. You see, we have 2.5, 3, 3, 2, 4. We never have anything below 1 or above 5. And so with that here, we basically describe to this dataset class what these data consist of, basically. So with that, we're going to create a data set, and its content is similar to the data frame, but you cannot actually see it. Oh, sorry, this has to be, sorry for the confusion. This is an argument, so it's equal to that tuple. So I was talking about the data set. You cannot see it here because it's a specific type, a dataset type, but be sure that the data are inside dataset. Right, so far we are at this point. We have created the dataset. The next step is to build the train set. So let's create a new cell here, build the train set. And this is going to be train set, so a variable which will be equal to dataset.build full train set. So that's a method. So execute that. And you're going to ask, well, what is train set? How does it look like? Again, it doesn't show, but of course, you can always convert these things into list and see what you've got. But you need to apply an all ratings method here. And so you're going to see that basically this is the user IDs with movie IDs and the ratings. So basically another format of the dataset, which is needed next for the next step is training the ML model, right? Let's create a text cell here. Train the model. So, okay, so we train the model, but what is the model, first of all? The model is a predefined model which we'll get from the surprise library. From surprise, import SVD. SVD stands for singular value decomposition, and this is a specific model used to construct a matrix of users and items. So this is what we need for building the movie recommendation system. So this model now has to be trained, so it is designed that way. So it waits for training data. So we're going to feed this data to that model. So we import that SVD, and then we need to instantiate it with SVD. Let me create some space here with SVD. So no parameters needed here. And let's execute that. So that's the model. It's empty now, but we can feed the model now to the train set. So that will train the model with the train set data. So execute that. And so that will alter the model. And finally, we are at the phase of predicting user ratings. So yeah, let's give it a try. Let's look at the data, ratings.csv. So these are the actual data. So I'm gonna just get one user ID. So let's say I want to predict what rating would user 15 give to movie 1956. So that's a known data, but we can try it so that we can see if we actually get an accurate value which is close to 4 or not. So for that, we're going to do sfd.predict, and you need to give two values here. The first one is the user ID, which was 15, we said, and the second one is 1956. Yes, 1956. Execute that, and you're going to get this. And the estimated value for the rating is 3.1, so not so bad. If you want to get only the estimated value, you can just do .est here, and that will give you the actual number as a float. Otherwise, you have more data here. So that's the user ID we provided, that's the item ID. So the model is, the SVD model is designed that way to work with users and items. So it wouldn't work with other types of data if we add another type of data set. Our UI would be the value if we gave this the actual value. So in case we want to compare it, if we give here the actual rating like 4, and you execute that, our UI becomes 4. So just for information. But this is the actual estimated value, right? So normally you don't want to give that. And then we have the details. If the prediction was impossible, in this case, was impossible is equal to false, which means the prediction was actually possible. So that was how to train a model and how to predict values. You can lastly also validate the model. So let's do that as well. Let me delete this cell, create a new text cell, validation. We want to import this time from surprise, import model selection, and then use that model selection to call the cross-validate method, which gets the SVD instance, so the model instance, not the class. We want to validate the actual model instance using the dataset. So basically what we're trying to do here is we're trying to find the values of the errors, so how accurate the model is using those datasets. And then we're using a measures argument, you can define a list of kind of errors you want to know, like RMSE. So that is for root mean square error, and perhaps you also want the mean absolute error. So if you execute that, you're gonna get a dictionary with different data. So that is for the root mean square error, and that's for the mean absolute error, which looks okay to me. So that's also the feed time and the test time as well. So these are some metadata about the accuracy of the model. And that's machine learning in a nutshell. So that's a good introduction for you to understand what machine learning is. Of course, there are different models to predict different phenomena, but this is a good start for you how to do it with Python. So thanks a lot for following this, and I hope to see you in the next section. See you.